Hello guys, welcome to Tutorial Space with Ola. I hope you guys have been doing fine, and in today's tutorial we are going to be working on the cylinders for our Radial aircraft engine, and so we head right into it. I would activate the current project, the rotary engine. It should be Radial, but I activate this project and select on the assembly. So just like I do always, if you are new to this channel and you are yet to subscribe, I would like you to just take a second to go over to the subscribe button and click on it. If you really enjoy the content that you have seen so far, then you can also share to your friends and hit the like button for all the mind-blowing tutorials that you might have seen. All right, so we are in the assembly workspace right now, and we just head right into the work for this tutorial. We have a couple of parts to be assembled, so we go over to place up here, and we would be bringing them. Most of them are going to be called cylinder. So we have this, the cylinder base gasket, the cylinder head gasket, the cylinder head, the cylinder liner. I know that you probably don't have them labeled like this, but you don't have to be bothered, because I'm going to be placing in the description below the names I used to save them while creating the models. So if you go to the description section, you should see probably cylinder base gasket, for example, and then you could see that maybe while I was creating the parts, the name of the video is probably video 12 or video 13, and then there would also be a link there so that you can find easily how to model the part if you have not already done so. Alright, so we have this part here, and we also have the rocker arm bearing block, that should be R, LMNOPQR, rocker arm bearing block. Okay, yeah, we need this also, rocker arm axle and rocker arm bearing block. So I'll select on this. I still have this selected, and then we need spacer sleeve. So spacer sleeve, that would be this. All right, so I click on open and place all the parts in my workspace by clicking once. Okay, then I click on the escape button and we have our parts here. Alright, okay, good. So the first thing to do, like always, is to create a reference part, which is going to be grounded, and then the other parts are going to be constrained, using that part as a reference. So first of all, I would make I'll make this plane visible. So I right click on the plane and select on visibility. Alright, so simply I would place a constraint between this bottom face, is really quick, and this plane here. Alright, so we have this. I could cancel, this is moving around. I would also place a constraint, let's see, the XZ plane. I'll make this visible also, right? So we can see this, and what I would do, this is the cylinder. I would make the corresponding plane visible also. So that's the XY plane for this. So you will notice that these planes are parallel to each other. so I will constrain this 2 also. Alright, apply, cancel. I think I should also add this, the last plane, visibility constraint. So then I would constrain this plane to this and say flush, apply. Alright, perfect. So I'm just going to select all of these planes and make them invisible, because they are no longer needed for now. Okay, then I could still make this grounded. Pretty much it was already grounded because of the constraints I already placed, but you know. So very quickly in this tutorial, we are going to be bringing all this together, and the first thing to do is replacing the constraints between this and this part. So you notice that I've placed the cylindrical constraint here, apply, cancel. It still moves up, but you notice that cylindrical constraints have been applied between the two parts. And then the next thing for us to do is to align also the holes that we have here to each other. So it doesn't really matter the direction based on this point here, the flange points here, because this is symmetrical. All we need to do is to align the holes together with the ones on top. So I would say for this hole, let's make it cylindrically constrained to that, apply, and let's just bring about this hole at this point, surface. Alright, perfect. So we have this, and that is good. Then the next thing for us to do is we are going to be placing the cylinder head gasket between the both of them. And the purpose of the gasket is to serve as you know, a seal proof. I think that's what I should call it. So it's like helps to seal the space in between, because you know, when you bring two solids together based on microstructure, there's still going to be a little bit of space, so you know, fluid can flow out of it. So they bring a gasket which is able to deform and fill in those, or that little space, so that there would not be a leak of fluid. Alright, so we will just place, let me change this right now, the view style to technical illustration. Okay, so we will just place the constraints which are quite similar to what we've done. So first of all, we place cylindrical constraints here between, I need to see the arrow, that's going to be difficult to do. Alright, but then we know that it's there. And where is the part? It's hiding somewhere here, which I don't know why it is doing that. So let's okay, so it's here now, and then we just place that there for now. So the next thing also, home view, we would be bringing in this cylinder liner. So the cylinder liner, this itself is going to be what forms up the combustion chamber. So we'll just do this also, cylindrically constrained, and it's in the opposite direction, as you can see these parts down here. So we just oppose, and it is on top, apply, perfect, and cancel. Then we could drag this down a little bit, exactly. All right, so we have this, and the next thing we would be doing is to constrain this part, this face here, with this. Constrain this face with the bottom face here of the cylinder liner. Apply. Now we can place the cylinder top gasket on top of this liner here. Alright, having done this, the next thing is to bring this and align with this. So now that's completely sealed and we are set to go to the rest. So we would place a cylindrical constraint also with this part. I'm just going to select the face, hoping that it works. Yep, so it works. Apply and cancel. I will drag this down a little bit. Then also place cylindrical constraint between these holes and this. Alright, apply, and also this hole and this. The thing about this is, once you place two cylindrical constraints, most of the time it's best to use opposite corners. So once you place two cylindrical constraints like that, you can be rest assured that the rest of them are going to be properly aligned. So that's that. So we now make the cylinder base gasket to mate with this face. So the same purpose of the cylinder head gasket is the same thing that this cylinder base gasket does. It's just to seal off the possibilities of fluid escape. Alright, so we have all of this, and then the next thing to do is to bring this part and place here. But before we do that, I want to make a little bit of changes to this part. So I would select on it and say edit. It's a very minor change. So I think it would not be difficult to do. And so I'm just going to look for the proper part that was used in creating it. Alright, extrusion. So it's this 3. So what I want to do is I would like to increase the radius of this and also the radius of this part. So from here you can see that that's where I made the sketches. Edit sketch. Alright, so where I had 7, I would be changing that to 9. Okay, let's change the 9 first so they don't get into each other. So the 9 I changed to 11. Alright, and the 7 I changed to 9. It's a minor modification, and I think it should be easy to do if you created your parts following the procedures that I demonstrated in my video. Alright, so we just wait for this to happen. Okay, perfect, exactly what I want, and that is good. Let me see to confirm that the changes have been made. Measure, this should be 9. Perfect. Alright. We return now and we are good to proceed. Okay, before I bring this in, let's do the fastening of these parts. We know that from the view we have holes here that are supposed to connect this part, the cylinder, to the cylinder head. So we are going to be bringing in some bolt connections to make that happen for us. So I'll return this. Okay, let's leave it this way. I think. Nah. I'll do something. Let's use this for now. Alright. So assemble. Where is it supposed to be? Yeah. Place from content center. Alright. So we go to fasteners. Select. And bolts. Let's just select from here. Hexagonal head. And I'll select the hexagonal head. And we would be searching for a DIN, EN, we have them here, ISO, we have them here, 4014, DIN, EN, ISO, 4014. Alright, so I select on OK. And as usual, okay, let me not say as usual, but because some people might not know. The first thing to do in this case is to select the hole, the threaded hole. It's kind of difficult to do that right now. I don't know. The view is looking weird, but try your best to find your threaded hole. So I'll select on this, the threaded hole, and I select on the face to place the bolt. Alright. So if you notice, the bolt goes in, let's see, right. Okay, so it goes in perfectly and sits just below this part. So if I change the view, you can see what it looks like. So it goes in and sits to this point. Alright. So for the hole I was talking about, I'll just show you. Try to see if we could see it in another. Yeah. So you see a threaded part here. So that will be the hole you select. You select the surface itself, and then after selecting that, you select on the face to rest the bolt on. Alright, so in this case, since we have 4 identical holes, we make sure that this is checked. Insert multiple, which is a count of components, which is 4. And then having done that, we just let's see. Okay, I think this is good enough. Yeah, so we select on apply. And we have all of our bolted connections included here. So the reason why I had to increase the size of this, of the circles here, these surfaces, which we did, is just so that in the process of, I'm trying to make this as realistic as possible. In the process of assembling this in reality, you need there's I can't remember the name it's called right now. There's a spanner with a universal joint that you could insert the head into this point. So I just try to create an allowance for the head to go in. So I'm not really sure if there's anyone that could fit 9 millimeters. 9 millimeters is pretty small. Anyways, but then that's the purpose of increasing the surface diameter of this part. And also, if you remember when I was introducing the assembly parts, I stated that I don't know if it's we, I stated that I created the parts using millimeters based on the drawings that I had. And I figured out later on, which was quite late, but I couldn't stop at that point. So I figured out that the millimeters was actually really small. So but then it's just for demonstration purpose. If at all there's a need to manufacture this, we could just scale it up by multiplying by 10 all the parts, and then voila, they simply become centimeters. Alright, so we just go ahead. We are quite halfway done. And then the next things to do is we'll be bringing this noun here. So assemble constraint. We have these holes here, and they will serve as our points to enable our constraints. So I've selected on the cylindrical surface of this hole, and I select the cylindrical surface of one of these. I would select this. Okay, hold on. I need to make sure that it's in the proper orientation. So I say free rotate to this part, and okay. So I need it to be somewhat like this. Yep. So this it's in the proper position now. So I select on this cylindrical surface and select on the corresponding cylindrical surface here. Alright, let's see. Okay, yeah, this is what we need. Why are you doing this to me? Alright, so this is what we need. I apply, and I would place okay, wait a minute. So I can drag this up, but if you notice that the constraints are not enough yet, so then I'll place the constraint between this cylindrical face here and the other hole also. Alright, now this is good, and we make this face to rest upon this face. Apply. Perfect. So this is the kind of orientation or alignment that we want, so you should try your possible best to achieve it this way. But I think if you just do what I've just done, then you should have it the way I have it right now. Alright, so we bring these parts also. So first of all, I would just place cylindrical constraints between these two parts. Yeah. And let's say I bring this also and place it within this place. Apply and cancel. So we have this, but we need extra constraints to fit this properly. Alright, so what we'll do, which I always consider as the easiest approach, is to just mate the planes together. So we need the center planes for those three parts, and that's this plane. I make it visible. That's the rocker arm axle. Then what part is this? The rocker arm bearing block. That's a very large and long name. So I'll make this visible also. Yeah. And we also need the spacer sleeve origin. This is the plane visibility. Oh, that's not the plane. So you notice it should be at the center, but that's not what we have. So what I would do is I don't always like to create the new plane outside of the part. So I would have to edit the part itself so the plane is there. Because if I just decide right now to go over to 3D model and create a plane at the center, the plane is going to be part of the assembly tree. so it's going to be somewhere below here, but I want it to be within the part itself. So I would say edit this part. And one of the reasons why I think it's better to do it that way is so that when you make changes to the part itself, the plane should be able to adjust itself also, being the fact that it was created within the part. So make this plane invisible. So we've done this. So what I used, mid plane between two planes. Okay, return, and we do this, and we align all of those planes together. Assemble, constrain. First of all, let's bring this to, okay, apply. I don't know where that one ran to hide just now. Where is it? Okay, so it's here, and constraint also, and I'll select on this and this plane. All right, perfect. That's what we have. Okay. I could have easily just flushed this face to this face. But no worries, no worries, no worries. We're still good. So now I can make these planes invisible because they are no longer needed as of the moment. Visibility and origin, uncheck visibility. Perfect. Alright, so the last things we need to do is just to insert some parts from the content center. And first of all, we are going to be adding our circlips. So let's see. Since we're already here, so let's just go straight to countersunk, and we look for ISO. I don't know, I feel like I have to state this again. I don't know all these parts like over the top of my head. I think that's the expression. But I did a little bit of research, so let nobody be scared. So this is what we need: the ISO 7046-1 space Z. ISO 7046-1 space Z. And okay. So where we are placing this part is going to be here, right? To fasten this part, which is the, I think it's the rocker arm bearing block, yeah, to the cylinder head, yep. So we are going to be fastening them together. And the first thing to do is also to select on the threaded hole. Select on that, and since it's a countersunk screw, so the next thing is to select on the face. And yep, so this is also selected because the multiple insertion is checked. And then I'll just look at it this way to verify that it goes in the both of them. Having seen this, we click on check, and then we have the parts fastened together. Click on the escape button, and we have just one more thing to do. So we go back to place from content center, and we bring in our circlips this time around. Let's see. Circlips, shaft part. That's where you have circlips. Circlips here. We need external, and we are looking for a DIN 6799. So it's quite close. DIN 6799. Okay. I don't know why I'm laughing. Alright, so I select on this cylindrical surface here. Where is it? Where is it? Yep, I select on that, and I want it to rest on this face, so I select that also and click on apply. Shaft diameter, I don't really know what the shaft diameter is, but since this is highlighted, so I just say okay. I'm still going to check it anyways, but that's good. And also we place the same thing here, this cylindrical surface and this face. Check. Shaft diameter is 4 millimeters. Okay, so let's figure that out if that's true. So we've placed those two circlips, and I click on escape, tools, measure. Let's see what this diameter is. 3.2. D'accord. So I'll see 4 millimeters. D'accord. So that's fine. Perfect. Alright. So we have all of our parts assembled together. This was pretty much very simple compared to the last tutorial that was done, and I hope you guys enjoyed this. If you have any challenges whatsoever in doing the same things I just demonstrated, do not hesitate at all to contact me. You can place your comments at the comment section for me to know what's up, and then I can see how I can be of assistance to you. Alright, now my friends, you see that this is coming into place bit by bit, and soon enough we're going to have a complete radial aircraft engine. Alright. So if by any chance my admonishment at the beginning of this tutorial for you to subscribe to this channel was not emotional enough, I'd like you to consider that again and click on this subscribe button, especially if you enjoyed this tutorial. And also remember that if you don't have any of these parts, you can always check through the description to know where I created to find the links to the videos where I created those parts. Sadly, I wasn't giving comments when I was creating the parts. I don't know why I did that. But you can also find the parts dimensions in a link I placed at the discussion section of this channel, and it will direct you to a Google Drive where you can find the drawings. Some of them are kind of complicated, some are not complete, so I had to, figure out a way to make it work. As you can see, I just increased the I just modified some things here, so that's part of it. But you can be rest assured that at the end of the day, everything is going to work out perfectly fine. Alright guys, so hit the like button, the subscribe button, place your comments, share these videos, and I'll see you in the next tutorials. Oh yeah, true. Before you go, remember to save your parts. So I almost clicked on cancel. That would have been disastrous. So I'll save my assembly part cylinder sub assembly. Save. Alright guys, as always, keep watching this space.